then we have to convert this matrix into a row echelon form. So here is some process we are doing here. Directly we are multiplying first row with minus 3 by 2 and add into the second row, and multiplying first row with minus 3 by 2 and add into the third row. Okay, so minus 2 4 minus 2 0, then 0, this minus 3 plus minus 2 into minus 3 by 2, so that will be cancel out, 2 will be cancel out, so you will get 0 and here. Then we are multiplying first row with minus 3 by 2, right? So this 4 into minus 3 by 2, that will become minus 6, right? And 3 minus 6, that is minus 3. So this minus 3 is coming from that one. And then 0 minus 2 into minus 3 by 2, so 2 will be cancelled, minus minus plus, so plus 3 you will get. Similarly, when we multiply first row with minus 3 by 2 and add into the third row, the third row become 0 minus 5 5 0. Okay, and then now this matrix still not in row echelon form. Okay, this is second row, this is our leading entry, below that leading entry we don't have 0, so that's why we are multiplying second row with minus 5 by 3 and add into the third row. So the third row becomes 0 0 0 0. Okay, so the third row become 0 0 0 0. Second and third row are minus 2 4 minus 2 0 0 minus 3 3 0. Clear? Now okay, now this matrix in row echelon form, minus 2x1 plus 4x2 minus 2x1 plus 4x2 minus 2x3 is equal to 0, and then minus 3x2 plus 3x3 is equal to 0. Take x3 is equal to t, so x2 is equal to t, and hence x1 is equal to t. Because of, see, third column does not have any leading entry, so that's why we are taking x3 is equal to t. Put value of x3 is equal to t here in the second equation, you will get x2 is equal to t, and put the value of x2 and x3 here, you will get x1 is equal to t. So hence the eigenvector corresponding to lambda is equal to 1 is 1 1 1, right? Now take lambda is equal to 2 in equation 1. Here is our equation 1. Put lambda is equal to 2, so you will get minus 3 4 minus 2 minus 3 2 0 and minus 3 1 1. Okay, again lambda is equal to 2, we get lambda is equal to 2, right? So just checking one by one row, minus 3 4 minus 2, correct? Minus 3 4 minus 2, then put lambda is equal to 2 here, so you will get minus 3 2 0, so this is minus 3, okay, this is minus 3 1 0, and this is minus 3 1 0, right? Minus 3 1 0. Okay, so again we have to convert this matrix into a row echelon form, so that's why we are multiplying second row with 1 and add into the third row. So the third minus 3 4 minus 2 0, and then minus 3 1 0 0, this 0 0 0 0 and then multiplying first row with minus 1 and add to the second row, you will get minus 3 4 minus 2 0 minus 3 3 0 0 0. So again the third column does not have any leading entry, so take x3 is equal to t, corresponding to x3 is equal to t, you will get x2 is equal to t and x1 is equal to 2 by 3t, right? So we want to write down our eigenvector in an integer, so that's why we are multiplying third 3 of x in each eigenvector, so finally we get this eigenvector 2 3 3. Okay, next lambda is equal to 3, so put lambda is equal to 3 in the first equation, so you will get minus 4 4 minus 2. Okay, so this is minus 4 4 minus 2, and then minus 3 1 0 minus 3 1 0 again we have to convert this matrix into a row echelon form. So second row multiply second row with -1 and end into the third row. So the third row becomes 0 row, first and second row are as it is, and then multiplying first row with -3/4 and add into the second row. The second row becomes 0, -2, 3/2, 0, right? So our equation is -4x1 plus 4x2 minus 2x3 is equal to 0. Then -4x2 plus 3x3 is equal to 0. Now take x3 is equal to t, so x2 is equal to 3t/4 and x1 is equal to t/4. So hence the eigenvector corresponding to lambda is equal to 3 is, you will get 1, 3, 4. Taking the eigenvector x1, x2 and x3 as columns, we get the matrix P. This first column is for first eigenvector. What is our eigenvector corresponding to lambda is equal to 1, 1, 1, 1. So is coming from 1, 1 is 1, 1 is the first column, which is eigenvector of the lambda is equal to 1. What is eigenvector of corresponding to lambda is equal to 2? That is 2, 3, 3. So this is second column, and third column is for the eigenvector corresponding to lambda is equal to 3. So now this is our matrix P. Also we want to find the P inverse. Okay, so for that we have to find determinant of this matrix P. So here is the determinant of this matrix P, that is 1 into 12 minus 9 minus 2 into, you can see 4 minus 3, that is right, and then plus 1 into 3 minus 3, that is 0. So finally we will get 1, determinant is 1, clear. And using this method we have to find all the cofactor of each each value, each element of this matrix, right? We are finding the cofactor. So the cofactor of this first element 1, we are for that we use this notation C11, because of this element is in first row and first column, so that's why we use C11. The second cofactor for 2, for that we use C12, because it's in this 2 is in first row and the second column, so that's why. Okay, so just try to understand. Sorry, here we use A11, A12. You can also use C11, C12. Okay, so because of our matrix is A, so we use A11, A12 and all this. So now we obtain the cofactor of each element of P using this method. This is A11. Remove the first row and the first column. So what will you will get? 3, 3, 3, 4. So determinant of 3, 3 and 3, 4. You will get 12 minus 9. So that is 3. Okay. Then A12. Removing the second column and the first row, you will get this 1, 3, 1, 4. So that is 4 minus 3, 1, and because of its minus 1 raised to I plus j, where I is the number of row in which that element, and j is the number of column, right, in which our element is there. So minus 1 raised to 1 plus 2, that is minus 1, and into determinant 1, 3, 1, 4, you will get minus 1. So using that method you can find all the cofactors of each element, A13, A21, A22. Just see, right, here is our matrix P. So this is find the cofactor of this element. You will get 1, 3, 1, 3. So 3 minus 3, that is 0. Okay. Then find A21, A22, A25, sorry, A23, A31, A32 and A33. Now the first column of the P inverse of the adjoint of P is the cofactors of the first row of the matrix P. So A11, A12, A13. This A11, A12, A13 are exactly the first column of the adjoint of A. So that is 3 minus 1 0. See, 3 minus 1 0. Then the second column is nothing but the cofactors of the second row of the matrix P, right? Minus 1 3 minus 1 minus 5 3 minus 1. So this is minus 5 3 minus 1, and the third column is exactly the cofactors of the matrix P of the third row, of the element of the third row. So 3 minus 2 1, right? And P inverse is nothing but the adjoint of A. P inverse is nothing but the adjoint of A divided by determinant of P. So here is similar matrix that is equal to adjoint of P. So P inverse is this one, 3 minus 5 3 minus 1 3 minus 2 0 minus 1 1. Now this is our P inverse AP, 3 minus 5 3 minus 1 3 minus 2 0 minus 1 1 minus 1 4 minus 2 minus 3 4 0 minus 3 1 3 1 2 1 1 3 3 1 3 4, right? So this is a matrix multiplication. We use 3 matrix multiplication. 3 matrix we have to multiply. So first of all we multiply this 2 matrix. Just check it some of the elements, right? Not all the elements we have to check, that you can understand that how we multiply 2 matrices. All of them are 3 cross 3 matrices. Now how we multiply the matrix? Pick up the first row and multiply with the each column. So just checking the first row, minus 1 into 1 minus 1 plus 4. So minus 1 plus 4 and then minus 2. Okay, minus 1 plus 4 plus 2. So you will get 1. Then minus 2 plus 12 minus 6 minus, again I repeat, minus 2 plus 12. So that is 10, and then minus 6, that is 4. So here is 4. Okay, and then first row multiply with the third column, you will get minus 1 plus 12. So that is 11 minus 8. So 3. So 3. So first row is 1 4 3. Okay. Similarly, this second row multiplying with each column, you will get second row of this matrix, and multiplying third row with each column, you will get the third row of this matrix. Okay, and finally you will get this P inverse AP is 1 0 0 0 2 0 0 0 3. Now this is a diagonal matrix, and why we in the main diagonal elements 1 2 3. Clear? Why? Because of in our matrix P, the first column is for the eigenvector of the lambda is equal to 1. So that's why this is 1. The second column is exactly the eigenvector of the lambda is equal to 2. So that's why in main diagonal entries is second element is 2, and the third column is the in P, in matrix P. You can see this is matrix P. The first column is for the eigenvector corresponding to lambda is equal to 1. Similarly, this is for lambda is equal to 2, and this is for lambda is equal to 3. So that's why here we get 1 2 3. If suppose we are interchanging the first and second column, if suppose we are interchanging the first and second column, that means what? The first column is for lambda is equal to 2, and the second column is for lambda is equal to 1. So in that case you will get 2 1 3 here, right? So just try to understand how we make this P inverse AP. You can directly write down also P inverse AP. Okay, so this is quite interesting example, and this question this example was complete. Now this question was asked in 7 marks. So thank you.